Alright guys, today is going to be pretty quick and simple, at least that's how it's been the rest of the classes. So you're going to have plenty of time at the end of class to go over some homework problems, ask questions if you have to, because what's coming up on Tuesday? Partner quiz, yes, okay. So on page 143, we're going to wrap up this section on multiplicities and x-intercepts. Just as a review from yesterday, because we're going to see them a little bit more today, can we refresh ourselves on the three different types of multiplicities? What do the graph, or what do the x-intercepts look like if you have a multiplicity of 1 versus 2 versus 3? Do you have an idea? One goes straight through. Two bounces.
Third levels off.
Three levels off. Levelly. Okay, we have a new vocabulary word. It is level at the x-axis. So we're going to see those a little bit more today. What we're going to try to do today, though, is shy away from looking at a graph to help us out, and we're going to start to just look at numbers. Okay, how can the points, how can the numbers tell us what type of multiplicity we might have? So we're going to kind of step up the rigor a little bit, if you will. So we have this equation, and they do give us the graph, so we're going to reference that just a little bit, but we're going to try to see some values or numbers and how those are related to the x-intercepts. So in these two boxes, we're going to go ahead and calculate some different function values. I want you to go ahead, take a few minutes, try to find these numbers. If you have a calculator, you go ahead and use it. I don't think you should need it, though. I want you to find those values. So plug in -2, -1, 0, and 2, see what you get. Yeah?
H of -2 equals -9.
All right, hold on one second. Can we confirm -9?
Yep.
Check out? Okay. Do you have another one, Eli?
H of -1 equals 4.
Confirmation?
Yep.
Good? Okay. Zero.
Equals 3.
Good there? Okay. And then 2?
H 2 equals 7.
Yeah? Good. All right. So based off of these values and the graph, I want us to explore two things. Okay, and they're listed at the bottom of the page. So take a look at the first one. From the graph, clearly there's an x-intercept between -2 and 1. So here's -2, here's -1, there's the x-intercept. Okay, we can see that based off the picture. But I'm curious, if we were to take the picture away, how do these numbers still confirm that there's an x-intercept between -2 and -1? How can we use the numbers instead of the graph? I'll give you an idea, Eli. Yeah.
One of the numbers, the answer for h -2 is negative, and the answer for h -1 is positive. So clearly, it has to cross the x-axis in order for it to change from positive to negative.
Okay.
From negative to positive.
If your value is negative, you are below the x-axis. If you have a value that's positive, you are above the x-axis. So if you change from negative to positive, you had to have crossed the x-axis at some point. Does that make sense? Can we see that off the numbers?
Yes.
Okay, so we'll go ahead and say, since the y values change sign, okay, one's positive, one's negative, since the y values change sign, there must be an x-intercept between x equals -2 and x equals -1. Is that kind of logical? Common sense almost? Good. Okay. Let's check out the next one. Does the same reasoning, okay, our justification that we just wrote down, does the same reasoning apply to the x equals 0 and x equals 2?
No.
Why not?
Those are both positive.
No, because the y values do not change sign. So what's that telling us? If the y values do not change a sign,
Then there's no x-intercept between those h0 and h2.
okay. If you look at the graph though, okay, I understand that answer. If you look at the graph though, here's 0, here's 2, here's an x-intercept. So it's not that we don't have one, yeah?
It shows that it doesn't cross over, so it bounces off the axis.
Okay, so if it doesn't cross, we have two possibilities. We're either bouncing or we don't have one at all. Okay, again, we don't have the graph. So if we just have these numbers, we know for sure it doesn't cross the x-axis, but our only other possibilities are it bounces or it's not even near the x-axis at all. So we're not guaranteed an x-intercept, okay, like we are for the previous one. So no, because the y values do not change sign, there is no guarantee of an x-intercept. Okay. Even though there is one based off the graph, if we just look at the numbers, that's not enough for us to conclude that there is an x-intercept. Okay, we're not guaranteed. All right. So looking at these two outcomes, it seems like if we're only going to look at numbers, the only way we can conclude that an x-intercept actually exists is if we have this sign change. So that's a big thing that we're going to start to look for in a table of values. Okay, where can we identify those sign changes? We're going to write down that concept on the next page, okay, at the very top. So based on what we've just seen, what do we need to know in order to confirm the existence of a 0, the existence of an x-intercept? Say if we can see that the y values change sign, then there must be an x-intercept between the x values. So if we can identify the sign change, we know for sure there's an x-intercept. If we cannot identify a sign change, we have one of two options. Either there's an x-intercept that bounces, or there's no x-intercept at all. We would need a little bit more information to help us determine which one of those options is the right one, okay, but those are the only two conclusions we have. Now, I want to extend this a little bit more, okay? If we can identify a sign change in the y values, we know we cross through the x-axis. Can we determine the multiplicity of that x-intercept if it crosses through? Think about our three options.
Possibly.
Possibly? Like what? Yeah?
So if it passes through, it could be 1 or 3, but you couldn't determine which one is that.
There you go. So, without having some more information, okay? So, if you think about our multiplicity options, we either go straight through, we bounce, or we go through levelly. So, the only ones that actually go through the x-axis are the multiplicities of 1 and 3. So, let's go ahead and write that down. We know we have an x-intercept between the x values with a multiplicity of 1 or 3. Like Emma said, we would need more information to determine if we go straight through or levelly through, but at least we know we're going through. All right, so we're going to use this concept, looking for this sign change in the y values, to take a look at this kind of chart example. Now, do me a favor, because there is a typo. Can you change this 3 to a 2? All right, so looking at this table of values, it says that it represents a quartic function. What does that mean? Quartic, you think, Eli?
There are 4 multiplicities.
Power of 4. Okay, there you go. So the highest power we have is a 4. The function has a negative root, okay, so a negative x-intercept, and 2 positive x-intercepts. So graphically, we know that there's 1 x-intercept on the left-hand side and then 2 x-intercepts on the right-hand side. So we have this little diagram to help us out. Okay, answer the following questions based off this table. So taking a look at number 1, are there any x-intercepts that are specifically labeled in the table? Out of all of these numbers, out of all of those points, can we find one of them, or more than one, that is an x-intercept? Do you see one, Emma? Yeah?
The point 1.
X equals 1 because? How'd you know that was a x-intercept?
Because the y value is 0.
Because the y value is 0. Okay, so y value of 0 means you are on the x-axis. All right, so looking at that y value, 1 would be an x-intercept. Now, based off of this x-intercept, let's see if we can determine the multiplicity of that x-intercept. So right here, at this x location of 1, we need to somehow determine if we go straight through, if we bounce, or if we go through levelly. How do you think the table can help us determine how we behave at that spot? Bless you. Multiplicity of, yeah?
And we can look at the y value surrounding it.
Okay.
See if it's just signs or anything like that.
Okay, so the y value before the x-intercept is negative, so that means you're below the x-axis on the left. And then after the x-intercept, your y value is still negative, so you're below the x-axis on the right. What multiplicity does that look like? Yeah.
2.
Multiplicity of 2. Good. Because there is no sign change in the surrounding y values. Okay, we picked a point on the left and a point on the right, and we saw that they were still the same sign. Can we see that? Can we make that connection from the table to a graph visually? All right, let's try number 2. Between which two x values is the negative x-intercept located? Can we look at the table? What do you think, Eli?
40 and 8.
40 and what was the other one?
Well, 40. So negative 4, negative 1.
Negative 4, negative 1. So why those two?
Because if you look at the y values, it changes signs.
There we go. All right, so between x equals negative 4 and negative 1, because the y values change sign. Notice how the question itself wasn't asking us to find exactly where the x-intercept was located. It just wanted us to determine a little region where it's located. So we know somewhere between negative 4 and negative 1 there's an x-intercept. We just don't know exactly, but at least we have a good idea where it is. Can we use kind of some similar logic for 3, between which two x values is the other positive root located? Go to Emma.
3 and 5.
Between 3 and 5. All right. Between x equals 3 and 5, because the y values change sign. We go from negative to positive. We doing okay? Yeah? Okay. We're not quite done yet. I want to add another question in here, even though it actually wasn't listed on the paper. So if you look at number 1, they wanted us to determine the multiplicity of this first x-intercept that we found. I want to try to do the same thing for these other ones. Okay? We don't necessarily know where these x-intercepts are located, but can we think about what the graph looks like at those spots? If the signs change, what are our only options for the multiplicities? Yeah? 1 or 3. Good. So you're going to say 2? Good. So how can we narrow it down? Do we have enough information to help us determine, is it 1? Is it 3? Is one of them 1, the other one 3? How can we figure that out? What do you think, Lucas? You can't? Okay. I mean, that's always an option, right? You can't. But we can. In addition to the 3 multiplicities we had yesterday, there was a 4th connection that we briefly discussed between the multiplicities and the type of function we have.
This,
Can we look back to yesterday? What do you think, Emma?
And you can try and see how many times the x value can be divided into.
Okay, so that's what we're trying to find. We're trying to determine how many times it goes in evenly. That's our definition of multiplicity. What is our 4th connection? What do you think, Autumn?
Since it's a quartic function,
Uh-huh.
each, like for the multiplicity has to add up to 4, so there's already 2.
Mhm.
So each one has to be 1.
There we go. All right, so since we have a power of 4, we need to take all the individual multiplicities, add them up, and we should get 4. So this one we already said was 2, okay? And if we have to add up to 4, there's no way one of these could be 3, because then you'd be at 5 and that would be too much. Does that make sense? Okay, so then both of these would need to have a multiplicity of 1. So 2 plus 1 plus 1 will give us that 4 that we had from the directions. Okay, that quartic function. So in this case, we did have enough information to help us determine, was it a 1, was it a 3? I'm not saying you'll have that all the time, but in this case we did. All right? So, sounds good. Okay, so we're going to stop there from this section. You have the rest of the period, which is a solid like 15 or 20 minutes, to try to go over some homework problems, ask some questions, get prepared for Tuesday.